Hey everyone, I am absolutely pumped for today's explainer because we are looking at something that is literally everywhere yet completely invisible. We are talking about friction. Friction is basically the ultimate physical frenemy. It's that invisible force that constantly stops us in our tracks, slowing us down when we just want to coast, but paradoxically, it's also the exact same force that allows us to walk, to drive, and essentially not float away into total uncontrolled chaos. Today we're pulling from some incredibly fun source material, specifically a series of massive, scaled-up science experiments to literally prove how friction governs our reality. We're going to be looking at everything from the basic physics to actual fire extinguisher-propelled racing.
All right, let's dive right in. Here's our roadmap for today's explainer. The force of friction, decreasing it, increasing it, some wild hover disk races, and finally, what life without friction would actually look like.
So, kicking things off with Section 1, the force of friction, the invisible force controlling movement.
Let me ask you something completely relatable to start. Why on earth can't you slide smoothly across a carpet? I mean, if you're in your socks, you can pull a risky sliding across the room move on a shiny hardwood floor, right? But try that exact same move on a thick, shaggy living room rug. Yeah, you're going to instantly stop and probably faceplant. So what's the actual physical difference there?
Well, the answer brings us to our core definition for today, friction. It's a force that is literally everywhere, and it kicks in anytime one thing rubs against another. Even when we invent clever workarounds to, cheat friction like roller skates with smooth wheels to cut down on that rubbing, you still can't roll forever. The tiny bits of friction inside those wheel bearings and against the pavement, they eventually sap all your energy and you come to a stop. It's just an inescapable rule of physics.
And because we know this force exists, we're constantly designing tools to manipulate it. Take a look at these two completely opposite examples. On one hand, we actively try to create high friction, like with soccer cleats. We literally strap metal spikes to the bottom of our shoes just to aggressively dig into the grass and give an athlete traction. But then, on the flip side, we intentionally try to create low friction, like with snow skis. We make the bottom of those skis as perfectly smooth and flat as humanly possible, so the skier can just glide effortlessly with almost zero resistance. It's like we're constantly playing this high-stakes game of tug-of-war with friction.
Moving on to Section 2, gliding, decreasing friction, or as I like to call it, the quest for zero resistance.
Our source material highlights this absolutely brilliant yet super simple DIY experiment to build a mini hovercraft, and it is so clever. Basically, you cut a circle out of some cardboard, poke a hole right in the middle, and glue a sports drink bottle cap over that hole. Then you blow up a balloon, stretch it over the closed cap, and the magic happens when you pop that cap open. The air immediately rushes down through the hole, and that escaping air actually creates a microscopic cushion between the cardboard and the table. It literally separates the two surfaces so they can't rub together. Boom! You just drastically decrease the friction, and your piece of cardboard is suddenly gliding around like it's on a sheet of ice.
Now, what's really interesting about this is what happens when we scale that exact same science up to human size. The folks in the source experiment headed over to a massive science center to build a totally rideable version. So instead of a tiny cardboard circle, they grabbed a giant sheet of heavy wood. Instead of a little hole, they wrapped the bottom in a tarp with a bunch of vent holes, and instead of a balloon, they rigged up a dryer vent tube and powered the whole thing with a high-volume leaf blower. But here's the thing, it's the exact same principle, just maxed out to lift the weight of an actual full-grown person.
And well, it absolutely worked, but it also led to this hilarious, slightly terrifying quote from the test rider. "I'm going towards the wall. It's like human air hockey." You see, defeating friction completely comes with a pretty massive catch. Friction is actually what gives us the ability to steer and to hit the brakes. When you totally wipe out the friction between yourself and the floor using a massive cushion of leaf blower air, you lose literally all control. You just end up floating aimlessly in whatever direction you got shoved, completely at the mercy of momentum.
Okay, I want to take a super quick, slightly random, but honestly fascinating science break that popped up in our source. The number 9,000. Any idea what this represents? Well, carbon is a basic building block of life, right? It makes up diamonds, it makes up coal, and it makes up you. Well, if you were to somehow extract all the carbon atoms out of an average human body, you would actually have enough to manufacture 9,000 graphite pencils. How crazy is that? Just a fun, bizarre fact to keep in your back pocket for your next trivia night.
All right, let's pivot to Section 3, gripping, increasing friction, the endless struggle for traction.
So picture a little toy boat sitting on a completely bare wooden ramp. If you tilt that wood ramp even just a little bit, gravity takes over and the boat just slides right down. The friction between the smooth wood and the boat is incredibly low, so gravity easily wins the fight. But what if you cover that exact same ramp in thick carpet? Suddenly you have to tilt it much, much higher before the boat finally starts to slide. That carpet adds a massive amount of friction, literally gripping the boat and actively fighting against the downward pull of gravity. And just like they did with the hovercraft, our source decided to scale this up to human proportions. They built this absolutely massive ramp. At a moderate angle, a person wearing just normal street shoes slid straight down. Gravity won effortlessly. So, to fight back, they added carpet to the ramp to crank up the friction, which actually allowed the person to climb. But then they made the ramp incredibly steep, like almost vertical, and suddenly the carpet just wasn't enough anymore. To conquer that kind of extreme gravity, they had to bring in the heavy artillery, the ultimate high-friction material, Velcro. By wearing a full Velcro suit and placing Velcro handholds on a Velcro-covered ramp, the friction was so intensely high that the climber could literally stick to the wall and easily pull themselves straight up. Seriously, extreme friction equals extreme grip.
Which brings us to Section 4, the hover disc races, putting friction to the ultimate test.
Okay, so the experimenters set up a showdown. They took 2 of those crazy leaf blower-powered human hover discs we talked about earlier. Now remember, the discs themselves have virtually zero friction with the floor, right? But the racers still needed a way to manually push themselves forward to win. So Racer A was handed a dust mop, a super soft, smooth tool with incredibly low friction. Racer B, on the other hand, was handed a pole with giant rubber balls on the end, and rubber is a material famous for having highly aggressive grip and friction. And the result? Well, it was exactly what physics would predict. The racer with the dust mop just awkwardly sat there spinning in circles. The mop lazily slipped and slid against the shiny floor, providing absolutely zero grip to push off of. Meanwhile, the racer with the rubber balls easily cruised to victory. That high-friction rubber aggressively grabbed onto the floor, allowing the racer to literally shove their floating disc forward. And honestly, this is exactly why we use rubber for our car tires and the soles of our running shoes. We absolutely have to have that grip to propel ourselves anywhere.
As a really cool quick detour, the source material also took a trip to an indoor skydiving facility. And this perfectly highlights how even a gas, like the air we breathe, actually has friction. When those giant industrial fans blow air upwards fast enough, the friction of all those billions of air molecules violently rubbing against your body creates enough upward force to entirely counteract gravity. You are quite literally floating on a cushion of air friction. It's wild.
And this brilliantly illustrates what happens when you introduce completely unbridled thrust into a frictionless environment. For round 2 of the hover disc race, they completely ditched the mops and the rubber poles and decided to use heavy-duty fire extinguishers, pointing them backwards to shoot themselves forward. I mean, what could go wrong? Without any friction between the disc and the floor to stabilize them, it was absolute, pure chaos. The massive thrust simply caused them to spin wildly out of control, kind of like a car with completely bald tires trying to drive across a frozen lake. It proved definitively that raw power is totally useless if you don't have the friction to actually control it. And that leads perfectly into Section 5, Life Without Friction, the Big Picture. I want you to genuinely just think about this for a second. What would our world literally look like without friction? Let's say some sci-fi supervillain pushed a big red button and just turned off the physical property of friction right now. What would happen to you and everything around you? So, the crucial point is, it would be an absolute unmitigated disaster. Just take a look at this list. Without friction, your car tires couldn't grip the road, so turning or even stopping would be completely impossible. The microscopic friction that holds the tiny threads of bolts and screws together, that would vanish, causing buildings and machines to just instantly fall apart into pieces. Adhesives like glue would completely fail. Heck, even the dirt wouldn't be able to hold the roots of trees anymore, meaning the absolute slightest breeze would literally blow entire forests away. Everything would constantly, endlessly be in chaotic motion. And really, that is the ultimate takeaway of this explainer. Friction truly is the ultimate physical frenemy. Sure, yeah, it's super annoying when it slows down our roller skates, or makes shoving a heavy couch across the living room exhausting, or forces us to pedal harder on a bicycle. But without that constant resistance, without that invisible grip quietly holding the atoms of our world together, absolutely no controlled movement would ever be possible. It is quite literally the anchor of our physical reality. So I want to leave you with this one thought. The next time you're confidently walking down a hallway, or steering your car around a corner, or frankly, even just sitting stably in a chair without awkwardly sliding right off onto the floor, just take a second.
Ask yourself, how is friction holding my world together right now? Because I promise you, once you start looking for this invisible force, you will realize it is brilliantly and wonderfully holding your entire life together. Thank you so much for joining me on this explainer, and hey, keep looking for the science in the everyday.